Hey guys, in this video we're going to be talking about how to find the sine, cosine, and tangent of our angles on the unit circle. And this meme that's shown right here will make a little bit more sense after today's lesson. So our objective, just to be able to find and identify the sine, cosine, and tangent values of the unit circle. So this slide is just kind of a review of last class. You're more than welcome to, take a look at some of those. So if we have the angle, 5 pi over 3, you got to think about where is that located. It's located in quadrant 4. And you should remember for your pi over 3s, your normal coordinates are 1/2 comma root 3 over 2. But when we're in the fourth quadrant, the x is positive and the y is negative. So you're more than welcome to take a look at these angles by yourself for a moment and press play when you're ready to go over them. All right, so 2 pi over 3 is in the second quadrant. And again, it's the pi over 3 family, but now the x is negative and the y is positive. All right, negative pi over 4 is down in the fourth quadrant. And when you're in the fourth quadrant, it's a positive x and a negative y. 7 pi over 6 is going to be in the third quadrant. And your pi over 6's look very similar to pi over 3, but we start with root 3 over 2, and then it's 1/2. But in the third quadrant, both are negative. So it's going to be negative root 3 over 2, negative 1/2. Okay, so negative 3 pi over 4 is going to be in the third quadrant as well. So both are negative. So negative root 2 over 2, negative root 2 over 2. Sorry, left off the root there. All right, negative 5 pi over 6 is going to also be in the third quadrant. It's the pi over 6 family. So both are negative. So negative root 3 over 2 and negative 1/2. And then 13 pi over 3, so that is not normally on our unit circle, right? Because that means we've gone around the unit circle a few times. So 6 pi over 3 would take us around the unit circle once. So 12 pi over 3 would take us around twice. So 13 pi over 3 is just one more pi over 3. So this is actually in the first quadrant. Okay. And it's pi over 3 family. Both are positive. So it's going to be 1/2 comma root 3 over 2. All right, so let's take a quick review here from what we know from geometry. Okay, so in geometry, we learned about sine, cosine, and tangent. We learned kind of just the basics. All right, so I've set up a picture for you there. We've got a terminal side, we've got theta, our angle. All right, and we can draw in, a right triangle here. Okay, so if this is our angle, okay, the side across from it we call the opposite. That's my opposite. Okay, the side right next to it we call adjacent. Now you might be saying, well, there's two sides right next to it, but the other side that's right next to it is across from your 90-degree angle. So that makes that side our hypotenuse. Okay, which on our unit circle happens to be our radius. So let's remind ourselves of our ratios here, because that's what sine, cosine, and tangent are. Sine, cosine, and tangent, you can remember these ratios by thinking back to your good old geometry days of SOHCAHTOA. There's lots of ways that you can remember that. I remember it just by knowing SOHCAHTOA. So sine is your opposite over your hypotenuse. Okay. Cosine is your adjacent over your hypotenuse. Okay. And tangent, TOA, is your opposite over your adjacent. Now, if we look at the unit circle, we look at this, drawing that we have here, you'll notice that the adjacent side represents your x distance, okay? And your opposite side represents your y distance. So we can also think about sine as really being y over the hypotenuse. Okay, we can think of cosine as being the adjacent, the x over the hypotenuse. Okay, and we can think of tangent as being y over x. Okay, so since your radius, though, of your circle is 1, okay, x is equal to the cosine of theta. So cosine of theta, x over 1, it's just x. Okay, so your x value represents your cosine of your angle. Okay, for sine of your angle, that's your y. And tangent is still the same thing, y over x. But something to remind yourself of, okay, it's okay to have 0 on top. When you have 0 on top of a fraction, the answer is just 0. But it's not okay to have 0 on the bottom. So, okay, no, this is a definite no. That means we're undefined. All right, so in order to evaluate each function, we need to know our terminal points, okay? And these terminal points, okay, I'm going to run through pretty quickly. We already know them, okay? You need to memorize them. So 0 and 2 pi, the terminal point for both of those is 1, 0. Pi over 6 is going to be root 3 over 2, comma 1/2. Pi over 4 is root 2 over 2, root 2 over 2. Pi over 3 is 1/2, root 3 over 2. Pi is -1, 0. And 3 pi over 2 is 0, -1. Okay, so remember, because we're dealing with a unit circle, our radius is 1. Our sine is going to be y. Our cosine is going to be x. And our tangent is going to be y over x. Okay. All right. So let's just run through those really quick. So if we're just doing sine, and that's just our y values, I'm literally just copying down my y values that I see over here on the left. Whoops, root 2 over 2. That's root 3 over 2. That's 0. That's -1. All right. My cosine, I'm just copying down the x's. So 1, root 3 over 2, root 2 over 2, 1/2, -1, 0. Now tangent, we're doing y over x. So I'm literally going to take these numbers, these purple and blue numbers, and just make them into a fraction. So 0 over 1, that's just 0. So the tangent of 0 is 0. The tangent of 2 pi is 0. That's what that means. Okay. The tangent of pi over 6. So that's going to be 1/2 divided by root 3 over 2. But whenever we divide fractions, we keep, change, flip. All right. So it becomes a multiplication problem. The 2's are going to cancel. And now I have 1 over the square root of 3. I can't leave the square root of 3 in the denominator. I have to rationalize that. We talked a little bit about that last class. So I'm going to multiply by root 3 over 3. That becomes root 3 up top and just a plain old 3 in the bottom. Okay. So the tangent of pi over 6 is root 3 over 3. All right. Now you might be saying, oh my gosh, another set of fractions, but root 2 over 2 divided by root 2 over 2 is just going to be 1, right? Because if we keep change, flip it, this cancels, 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 1. So tangent of pi over 4 is 1. All right, for pi over 3, so keep, change, flip, cancel, cancel. Oh, it's just square root of 3. Don't have to do any rationalization there. Okay, 0 divided by -1 is 0. Okay, but -1 divided by 0 is undefined. So you cannot find the tangent of 3 pi over 2. It's undefined. All right. This over here is a tool to kind of help you out. It's an acronym. All students take calculus. Now, that's not necessarily a true statement, but you can definitely use it to help you out. So, but what it basically tells you is that every single function, sine, cosine, tangent, they're always going to be positive. They're going to be greater than 0. Your signs are going to be greater than 0. All right. In the second quadrant, any sign that you take is going to be positive. In the third quadrant, any tangent you take is going to be positive. And in the fourth quadrant, any cosine you take is going to be positive. All right, so here's some examples down at the bottom. Feel free to pause the video, try them on your own, and when you're ready, press play. I'm just going to kind of give you the answers here. The cosine of pi over 4 is √2 over 2. The cosine of 2 pi over 3 is √3 over 2. The cosine of 120 degrees. Now this one, we should convert 120 into radians by multiplying by pi over 180. Whoops, I accidentally put an extra 180 there. And that reduces to 2 pi over 3. So this is cosine of 2 pi over 3. And cosine of 2 pi over 3 is -1/2. 210 degrees is the same as 7 pi over 6, and the sine of 7 pi over 6 is also -1/2. Tangent of -pi over 4 is -1. Sine of 180, 180 is the same as pi, sine of pi is 0. Tangent of 7 pi over 6 ends up being √3 over 3. And tangent of 270, 270 is the same as 3 pi over 2, and you can't find the tangent there. It's undefined. So that's sine, cosine, tangent.